There's one new thing that you will be learning in H2 Math vector, which is this unit vector. Unit vector is very, very simple, okay? Especially those of you who were confused somehow during your first semester about unit vector because you try to pump a lot of ideas into unit vector. There's actually just one single thing about unit vectors that you need to know. Just one single thing. That is the core definition of unit vector. There's nothing else. If there were to be anything else that you are going to be seeing unit vectors appearing, it is all riding on this one single thing. What is that one single thing? Unit vector, if I say that this vector is a unit vector, that means this vector has a magnitude of 1, full stop. That's all about unit vector, okay? If I say that, hey, A is a unit vector, its magnitude is 1. I just want to make sure that you are clear that I'm talking about magnitude, because there are some students who think that a unit vector is this 1, 1, 1. This is not a unit vector. How do you check whether a vector is a unit vector? You just go and find its magnitude. Its magnitude is square root of 1 square plus 1 square plus 1 square. This is square root of 3. Since its magnitude is not 1, then it is not a unit vector. So there's only one single definition. The moment when the question tells you that, hey, this vector is a unit vector, its magnitude is 1. That's the only thing that you know about that vector. That's the only thing that you are supposed to extract from that statement. This vector is a unit vector. Then what is this formula or whatever this is here? You know, this is not confusing at all unless you try to confuse yourself about this being so like is this a definition of unit vector? It is not. If I have a vector, I'm going to call this vector A. And let me give you an information about this vector A, okay? So if this vector A has a magnitude, has a length of 5, okay, this length is 5. Scalar quantity, okay, its length is 5, so it is 5 units long. This vector A is 5 units long. Then I want to get a vector, a small little vector, and this vector is supposed to have just 1. Length is 1. So you're going to try to cut this. You know, you can cut this. So how do you think you will cut this A, vector A, to get a vector that has a magnitude of 1? Benjamin, how do you think you will cut this vector A so you can get another vector with a magnitude of just 1? Any suggestion, Benjamin? Benjamin say doing a scalar multiple of 0.2. 0.2 is 1 over 5. Right? You just want to shorten this by 0.2, which is 1 over 5. So what Benjamin suggests is, I just need to take 1 over 5 of this vector A, or the number that Benjamin has used, 0.2 multiplied by A. I mean, it's just trying to scale and shorten this by 5 times, correct? So if this is not 5, if let's say this is a magnitude of 3, so what do? You just cut it into 3 parts, because every single part of it is going to have a magnitude of 1. Okay? So what if this magnitude, I mean, let's generalize this, okay? What if this magnitude is not just, not 3 generalized? What is the magnitude of a vector A? If it is not numerical, then notation-wise, it is going to be this. Then I just try to scale it again. I mean, if its length is modulus of A, then I just do a 1 over A. You automatically scale it down to whatever vector that I have, whatever vector, which definitely is going to give me a magnitude of 1. That is what we are seeing here. A unit vector has a unit vector that is derived from another vector has a notation. The notation is p hat with a little thing on top, a hat on top. So it is this b hat. That means the moment when you see b hat, you know that it is derived from the original vector p. So it is going to be k times of p. It will bear the same direction as p. It will be still parallel to p, because it is just scalar multiple of p. It's just that b hat is not any vector that is parallel to p. It is derived from p and it has a magnitude of 1. So how do I get that kind of vector? We'll do exactly this. We just do simple proportioning. So this is a scalar multiple. I will just go for 1 over, if the length of p is 5, I'll do a 1 over 5. If the length of p is 3, I'll do a 1 over 3. If the length of p is modulus of p, I'm going to divide this by modulus of p. And please take note that 1 over modulus of p is a scalar quantity. So this is a number, this is not a vector. So this number multiplied by this. It is like this 0.2 here. It is like the 5 that is here. It is like 5. So this is like this portion here, which gives us this. So please don't see this as something that is very complicated, okay? It is just a notation that we want to get used to. I don't even need to memorize this as a formula, although it is good. You know, if I can just know this as a rule, then I don't have to keep thinking about this, which wastes probably a few microseconds of my time processing it, but I guess whichever that works. Okay? For example, let's try something simpler, okay? Let's take a look at question number 3 in our worksheet. Any question? We are just doing proportioning, okay? So I'm a bit scared that as I do more and more unit vectors, then some of you are starting to think that unit vectors are defined by this, defined by this, defined by this. Unit vector is defined by this, it is not. Okay, so I want to just repeat one more time before I proceed to this is, unit vector has only one definition. It is when a vector has a magnitude of 1, then it is a unit vector. If you want to do this, it is your choice. It is maybe what the question demands from you. It is not because it is trying to redefine unit vectors from any other perspective. Because unit vector just simply means that its magnitude is 1. But there are some famous unit vectors that you can definitely try to memorize. You know, three very common notation that represents a unit vector will be I, J, and K. When you see I, automatically in your H2 Math, okay, when you see I, it means that it is a position vector, so it starts from the origin, and it is 1, 0, 0. So it is a unit vector that is pointing in the x direction. It's a position vector that is pointing in the x direction. J is a unit vector that starts from the origin that points in the y-axis direction. And K is a unit vector that is going to be pointing in the z direction, a position vector. So if you see a vector that is like this, for example here, vector A is given to you as 4i minus j plus k. I think most people will not prefer working with vectors that is in this ijk form. So I'm going to change this, okay? My personal preference, which I believe you guys should have this preference also, it will be 4 minus I1. 4i minus j plus k. And B is going to be I, which is 1, then j, which is 0, and k, which is minus 2. So 1, 0, minus 2. And the question tells me that 2a minus b plus c is equal to 0. But can you spot my mistake? Simple mistake.
0.
Okay. This is usually going to happen in your first test. So please watch out, okay? If you have to do this during your first test, they will probably minus 1 mark from you. I think subsequently for promo, they will still mark you wrong, but I don't think they will mark you, they will minus marks anymore. But in J2, they will start to minus marks again. J2, this kind of presentation, they are going to be very, very strict before letting you guys go for the A-level. So let's make sure that we don't miss out the fact that on the left-hand side is a vector quantity. So here it must be a 0 vector, not a 0. So that is also why the 0 that is here is bolded, because it is supposed to represent a 0 vector. We want to find the unit vector that is in the direction of C. So let's try to find vector C first. So vector C is B minus 2A. So it is B, 1, 0, minus 2, minus 2A, 4, minus 1, 1. This is equal to 1 minus 8 minus 7, 0 plus 2, then minus 2, minus 2, minus 4. So this is vector C. But we want, what I was saying, if this is vector C, we want a vector that is, we want a unit vector that is in the direction of C. It is in the direction of C. So we want this to be just 1. And like what I was saying, if this vector here, C has a magnitude of 5, then this vector, in order for it to have a magnitude of 1, I just need to take vector C, I chop it into 5 parts divided by 5. Or I can also write it as 1 over 5 vector C. So if this is not 5, if this is modulus of C, then this will be modulus of C here. This is going to be modulus of C here. So that's what I'm going to do. And I'm going to try to get used to the notation. So a unit vector that is in the direction of C is this C hat. I'm going to find first is magnitude, which is going to be 1 over modulus of C. Modulus of C is magnitude. Then multiply by the vector C. This is equal to 1 over, what is the magnitude of C? Square root of minus 7 square. The negative doesn't really matter. If you want to put minus 7 bracket square, it is fine. Then plus 2 square plus 4 square. Multiply by minus 7, 2 minus 4. This gives you a 1 over square root of, this is square root of 69. Then minus 7, 2 minus 4. Any question? Okay, 4 and 5, let's take a look at it. So let's take a look at this 4a. We are supposed to find this vector a. And this vector a is in the direction of 8i plus j plus 4k. I'm going to call that vector b. So I'm going to let vector b be this 8, 1, 4. And it is supposed to be in the same direction as this. And it will bear the same magnitude as another vector. I'm going to call this vector c as, I'm going to call this other vector as vector c. So it is going to be this 1 minus 2 minus 2. So 1 minus 2, 2. So if I have this, and the idea is this, okay? Let's say b is this. Let's say b is this. Let's say this is vector b. Let's say vector c is, for example, this vector c. So vector a must have the same direction as this vector b. That's what the question says. Vector a must be this same direction as vector b. But this vector a must possess the same magnitude as c. So this is the magnitude of c. I'm going to just use notation, magnitude of c. So a probably is not going to be this long. It should be having a length that is almost this. So this a will bear the magnitude of c. So this is what I'm looking for. A vector a that is in the direction of b and a vector a that has the same magnitude as c. Let me show you the strategy. The strategy is to make use of unit vector. You know what is so good about unit vector? The good thing about unit vector is very, very scalable. It's scalable because its magnitude is just 1. So its length is already 1. Which means that if you were to take this vector times 5, what is the new length? Because its length is already just 1. If you do times 5 to it, you will adopt another length, right? 5. If the unit vector has a length of just 1. If you times 7, it's going to become a vector that has a magnitude of 7. So it's very scalable in terms of magnitude, the moment when you possess a unit vector. So if I were to apply that here, the first thing that I'm going to try to do is to find a unit vector that is in the direction of b. A unit vector that is in the direction of b. And a unit vector that is in the direction of b, I can use this notation. I will scale b with its own magnitude and I'll multiply it by the vector b. Scalar multiple of b is still going to be parallel to b. And because I proportion it by dividing it by its own magnitude, I scale it down, proportioning it down to a vector that has a magnitude of 1. It is a unit vector, so I use b hat to represent it. So it's going to be 1 over square root of 8 square plus 1 square plus 4 square, 8, 1, 4. And this is equal to 1 over 9 of 8, 1, 4, b hat. So now I have a unit vector that is in the direction of b. This is very scalable. By the way, are you convinced? Are you convinced that this is actually going to be one that has a magnitude of 1?
Yeah.
You're convinced? Okay, because there was one, I remember when I was in the secondary school, when I was in the JC, right, suddenly, okay, there's one point in time that I was like, are you sure this becomes a unit vector? Like, how can this be a unit vector? It looks so complicated. I don't believe that its magnitude is 1. So what I did was, okay, I just want to check whether its magnitude is 1. So I went to find its magnitude, 1 over 9, then 814. And 1 over 9 is a scalar quantity. So I can take it out of the modulus notation. That was what we did just now. Then we have 814. And this is 1 over 9. This is just going to be square root of 8 squared plus 1 squared plus 4 squared. I mean, we have already calculated it. It is 9. So we will get a 1 over 9 times 9. Cancel, it will become 1. Of course, it is going to become 1. Because if I were to try to find the magnitude of this, I can already see that it becomes 1, right? Because this is just a scalar quantity and it is a positive number. So it is going to be 1 over modulus of b. And I'm going to be left with a modulus of b inside the modulus. So I'm going to get a 1. So anyway, now I know that b hat, okay, it's a bit confusing, but b hat is equal to this. And the next thing that I want to do is, I'm going to find what is the modulus of c. So modulus of c, the length of c is going to be square root of 1 square plus 2 square plus 2 square. This is equal to 3. So now what is a? A will be in the same direction as b. I just want the direction of b, which I can get from b hat also. So it's going to be a scalar multiple. I'm going to be replacing this scalar number, okay? It's going to be a scalar multiple of b hat. Because it is parallel to b, and b is also parallel to b hat. So by saying that a is parallel to b hat, I'll automatically get vector a to be in the same direction as b. So what is k? What is its length? Because b hat has a magnitude of just 1. So its length, I want a new length to be 3. So I just multiply by 3 to it. So I'll take 3, multiply by b hat, which is going to be 3 multiplied by 1 over 9, then 814. So a is going to be equal to 1 over 3, 814. This is one practical usage, mathematical usage of unit vector. It gives me the possession of direction without complicating it with its magnitude, because I can immediately work on a vector with magnitude of just 1. Then subsequently with the unit vector, it makes it very, very easy for me to scale. Let's try it one more time. B.